afternoon everyone. I am Dr. Kusumita Kundu, Assistant Professor of Chemistry in SVIST. Today's topic is the RS naming, RS nomenclature. Okay. Now this RS naming is dependent on a rule that is known as CIP rules. Can't in bold pre-log, CIP rules. Okay. Now what does this rule say? Rule says that the RS naming is basically dependent on the priority order. Now this priority order is set by these CIP rules. CIP rule says that if the weight of the atom is higher, then it will be getting number 1 in the priority order. So it will get the highest priority. Okay. It will get the highest priority. If the weight of the atom is highest, then it will get the highest priority. And if there are two similar atoms, so it will be showing the same atomic weight. So if there is two similar atoms, we have to consider the next atom attached to that carbon atom. Okay. Consider the next atom attached to the carbon atom. Consider the next atom attached to the carbon atom. If the two atoms are similar, okay, I will show some examples. If the two atoms are similar, then consider the next atom attached to the carbon atom. So these two are the basically main of CIP rules. For example, this is one chiral carbon atom and there are 4 different substituents. So in between these 4 substituents, which one have the highest atomic weight? Br has the highest atomic weight, then Cl, then fluorine, then hydrogen. So, in this case, what will happen if the order is 1, 2, 3? Okay, that means it is in anti-clockwise. If the order is clockwise, then the configuration will be R. Okay, and if the order is anti-clockwise, then the configuration will be S. Okay. So in this case, the priority order is anti-clockwise. So this configuration will be S configuration. Okay. Let me give you another example. So what will be the first one? Cl, fluorine and CH3. So the priority order rotating will be like this. So this is R configuration. The rotation is clockwise. So this is R configuration. Okay. That's how we will find the configuration of the chiral carbon. And here there is also an exception. What is the exception? If the position of the hydrogen atom is anywhere but the vertically below, that means if the position of the hydrogen atom here, here and here, then if the rotation is clockwise, it will be S, and the rotation is anti-clockwise, it will be R. That means it will be a simply opposite if the position of the hydrogen atom is not here. Okay. For example, let's say hydrogen atom is here. Fluorine, fluorine, bromine. So bromine has the highest priority, then fluorine, then fluorine. So the priority order is anti-clockwise. So it would be S, but the position of the hydrogen is different from this atom. Here the hydrogen is vertically below. but here the hydrogen is basically left to that axis. So due to the position of the hydrogen, this molecule will be R. Okay, this molecule will be R. And if we interchange the position of hydrogen atom, then this molecule would be also an R configuration. Okay, that is how you have to find out whether the chiral carbon atom is R or S. Thank you so much. That is all.